2 for Physics 202. Number 1 asks, which of these equations correctly describes this circuit? Well, we'll just start with the first one. It says 80I3. That would be starting here and going against the current. And then the next one is plus 1I3, so that's not the next element, that's the wrong sign, so that's incorrect. The next one is minus 80I3. That's starting here and going in this direction. Minus 1I3, that's correct. Minus 30, you're going from high to low, so it should be minus. Minus 20I2, you're going with the current, so that's correct. Minus 40 is equal to 0, so the answer is B. Let's go ahead and look at the others though. This next one says I1 plus I2 is equal to I3. If we look here, the currents coming in are I2, and the currents going out are I1 plus I3. So that's what the junction rule should read, so that is not correct. And then we have 45I1 plus 20I2, so that's 45I1 that's going in this direction, plus 20I2, that would be coming down here, but that's the wrong sign, so that's not the right one. So B is the right answer. Which of these statements about a household circuit is true? The household circuit is a parallel circuit, that's true. All devices in a household circuit operate at the same current, that is not true. They operate at the same voltage or potential. As you add more devices to a household circuit, the potential across each device decreases. The potential across each device is constant. And so that's not true. The circuit breaker turns off if IN is greater than I out for any particular device. This is what a ground fault circuit interrupt does, not a circuit breaker. A circuit breaker turns off if you exceed a preset current, 15 amps, 30 amps, whatever. So that's not correct. So the answer is 1, that's option B. This circuit, how much brighter or dimmer is bulb A compared to bulb C if you assume they have the same resistances? We have 10 volts here, so since these are in parallel, this gets 10 volts. These two, bulbs B and C, share 10 volts, and they each get 5 volts. Since P is equal to V squared over R, A has twice the voltage of bulb C, so it means it is 4 times as bright, because you get a 2 squared, gives you 4 times the power, so that is option C. In this circuit, what happens to the equivalent resistance as you add resistors in parallel? The equivalent resistance decreases when you add resistors in parallel. Wire carries a current, sits in a magnetic field as shown. What is the direction of the force on the wire? You let your fingers go in the direction of I, that your hand has to flip over, your fingers fold in the direction of B, which is out of the page. That gives you a force that is up. So number 5, the option is C, that's up. What is the initial direction of this positively charged particle when it enters the magnetic field as shown? That is, what is the direction of the force? Velocity is to the right, magnetic field is down, right-hand rule gives you a force that's into the page. So the particle initially goes into the page when it enters the magnetic field. This figure shows the path of a charged particle. What is the charge of the particle? Alright, well, let's just imagine first that it's positive and ask ourselves what is the direction of the force. If our fingers go to the right, they fold out of the page into the magnetic field. So that gives you a force that's down. So if this was a positive particle, the force would be down. But obviously something is pulling it up, so it must be a negative particle because the force is up. So that is A. Which pole of a magnet points towards the magnetic north pole on the Earth? You have the northern geographic pole and the southern pole. But if you represent the Earth as a bar magnet, the southern magnetic pole is at the northern geographic pole, and the northern magnetic pole is at the southern geographic pole. So the pole of a magnet that points towards the magnetic north pole is the south pole of a magnet. So the south pole of a magnet points to the southern geographic pole. Another way to think about this is that the opposite poles are attracted. So you can just say a south pole of one magnet is attracted to the north pole of the other magnet, but the other magnet just happens to be the Earth. So the answer is south, and that's option C. The point A is equidistant between these two long parallel wires. What is the direction of the magnetic field at point A due to the two wires? Well, let's take the left wire first. Let your thumb go in the direction of the current, and your fingers wrap around, and due to this left wire, the magnetic field is out of the page. Due to the right wire, which is current going up, the magnetic field is also out of the page. So in the middle at point A, those two vectors add up constructively to give you a vector that is out of the page. That is option B for number 9. out of the page. Which of the forms of radiation in the electromagnetic spectrum has the highest energy? Well, radio is the lowest energy, so that's not it. Microwaves is the next lowest energy, followed by infrared, which is the next. So ultraviolet, which is just slightly higher energy than visible radiation, is the answer. That's B, ultraviolet. Which of these relationships correctly describes the indices of refraction depicted in this figure? Or if we trace out our rays, our wavefronts, in order to bend away from the normal, the velocity in medium 2 has to be greater than the velocity in medium 1, so that this side can move around more quickly. So if the velocity is greater, that means that the index of refraction for medium 2 is less than the index of refraction in medium 1. That looks like option B here. Number 11 is B. What physical property of glass allows for the creation of light dispersing prisms? Well, all these things are true. You know, prisms are triangular, light travels slower in glass than air, and the index of refraction in glass is higher than that of air. But C is the reason that glass, or really any kind of material, can produce, or most materials rather, can produce a light dispersing prism. It's because the index of refraction is dependent upon wavelength. So red light, for example, is refracted at a different angle from blue light. Which of these phenomena suggests that light acts as a particle? Interference is a wave-like quality. Reflection is particle. Refraction is wave. And photoelectric effect is particle. So we have options 2 and 4. That is B. This figure shows a person looking at a star in a box filled with water. The actual position of the star is as shown. What does the person see the image, or where does the person see the image of the star? So this is kind of like the fish problem in the concept test. If I trace out a ray, just like that, and then it bends away from the normal to the person's eye, and if you trace this back, you'll see that the image of the star is there. So that is to the right. That's option C. Okay. 10 and 20 ohm resistor in parallel, and the pair is in series with a 30 ohm resistor. And they're all hooked up to a 45 volt battery, so it's something like this. You have a 10, 20, 30. This is 45 volts. These are all in ohms. And I want to know what is the potential across the 10 ohm resistor. So I want to know what is the potential across this resistor. I first want to break down my equivalent resistance a little bit. If I take the equivalent resistance of these two, that's 1 over 10 plus 1 over 20. That's equal to 6.7 ohms. So if I redraw this, I get a 6.7 and a 30 ohm resistor. And then again, my equivalent resistance of that is just 30 plus 6.7, so that's 36.7 ohms. This is 45 volts. So my current flowing through this is I equal V over R. That is 45 over 36.7. That's equal to 1.2 amps. And then my voltage across let me draw it up here. My voltage across this resistor is equal to I times R. There are 1.2 amps going through that resistor times 6.7 ohms. That gives me a voltage of 8 volts. That is the answer, because the voltage across this resistor is the same as the voltage across this resistor and this resistor, because they're in parallel. So the answer is 8 volts. A particle carrying a minus 10 coulomb charge moves with the velocity is given here. What is the force and vector notation on the charged particle? Alright, we just want to do F equals QV cross B. Q is minus 10. And then V is 2J plus 3K. And then B is 6I plus 8J. I'm going to leave this minus 10 just hanging out here for now. I'm going to do FOIL. The first is 2 times 6, F-O-I-L, first, outer, inner, last. 2 times 6 is 12 times J cross I. outer is 2 times 8 is 16 times j cross j, but j cross j is equal to 0, so I'll leave O out, so it'll just be like, I don't know, fill. So I is for inner, 3 times 6 is 18, k cross I, and then last is 3 times 8 is 24, and that is k cross j. Now we need to figure out what are these cross products, the directions of these cross products, and finish out the multiplication. This is I, j, k. We can use the right hand rule to figure out what is the direction of j cross I. Let our fingers go in the direction of j, they fold towards I. That gives us negative k. K cross I. Let our fingers go in the direction of k, fold towards I. That gives us positive j. And then k cross j. Let our fingers go in the direction of k, fold towards j. That gives us negative I. So if I put this in, I get negative 10 times 12 times j cross a. That's negative 12k. Just substituting the negative k for j cross I. Plus 18k cross I. That's plus 18j. Plus 24k cross j. That's minus 24i. Then we just multiply by negative 10. And I'm going to reorganize in ijk. So I get 240i minus 180j plus 120k. And this is a force, so it's all in newtons. 240i minus 180j plus 120k. And that's the answer. Okay, wire of negligible resistance is bent into a rectangle as shown in this figure, and a battery and a resistor are connected as shown. There's a uniform magnetic field. As I said in class, it's not pointing into the page, it's pointing to the right, as shown in the figure. Find the magnitude and direction of the net force on the circuit. Okay, well, the first thing we do is we need to find the current in this wire. I is equal to V over R. That is 10 over 5, 10 volts over 5 ohms. That's equal to 2 amps. So there are 2 amps of current. Then I calculate my force, ILB sine of theta. That is 2 amps. The distance is 0.1 meters, that's 10 centimeters. And then the magnetic field is given in the problem, that's 2 Tesla. The angle theta is 90 degrees. So this is just equal to 0.4 newtons. So now we need to figure out what is the direction of this force. The current comes off the positive side, so the current is flowing in this direction. So if we let our fingers go in the direction of the current, they fold towards the magnetic field, which is to the right, and then that force is going to point out of the page. So you could either write out of page or in the plus k direction would also be sufficient. Either of those for the direction. Alright, number 18, trace the path of the ray thrown through the glass. The angle should be drawn in proper proportion. Calculate the angle of refraction when the light emerges from the glass. And as I said in class, this is an equilateral prism. So we have 60-degree angles all the way around. Here we're going from a index that's equal to 1 into an index that is bigger. That's equal to 1.5. And so we're going to bend towards the normal. And I was looking that you get that angle right in the proper perspective. And then when I go into this medium, going from a high index to a low index, it should bend away from the normal. Something like that. And I want to know what is this angle. Alright, to do that I have to first find this angle. I'll call this theta 2. And I say n1 sine of 30 is equal to n2 sine of theta 2. n1 is equal to 1. This is equal to 1.5. So theta, and this is equal to 30. So theta 2 is equal to the inverse sine of sine 1 sine 30 divided by 1.5. And so that angle is 19.5 degrees. So that's theta 2. Now if that's 19.5 degrees, this angle is 90 minus 19.5, which is equal to 70.5. And then further I can find this angle, which is going to be 180, which is the total number of degrees in a triangle, minus 60 minus 70.5. And that angle is equal to 49.5. And then finally, I want to know this angle. This is equal to 90 minus 49.5, which is equal to 40.5. And then I use that angle to find my final refracted angle, which I'll call theta r. So I do that same way. I say n2 sine of 40.5 is equal to n1 sine of theta r. And I solve for theta r in the same way as I did over here, and I get 76.9 degrees. And that's the answer. And then also part of the answer was drawing these rays the correct way. Alright, in this figure, a boy shines a flashlight so he illuminates the keys at the bottom of the lake. What is the distance from the pier to the keys? That is, what is the distance x as shown in the figure, and the index of refraction is 1.3. So there are two triangles here. We first need to find out what is one of the angles in the triangle, and that's theta 2. So I'm going to do that first. That is, what is this angle right here, and then we'll approach the two triangles. I use the index of refraction, or the law of refraction, which says that 1 sine of 40, n1 sine of 40, but n1 is equal to 1, is equal to 1.3 sine of theta 2. And then I solve that for theta 2, and theta 2 is equal to 29.6 degrees. Now, I'm going to be looking at this triangle and this triangle. I want to solve for x1 and x2, and then x is just going to be the sum of those. So taking this first triangle right here, I know that this angle is 40, so this angle is also 40. This is x1, and this is 1 meter. I can say then that the tangent of 40 degrees, which is opposite over adjacent, that's x1 over 1. So x1 is just equal to the tangent of 40, which is 0.84. Now, take this second triangle. This angle, we've already found, is 29.6 degrees, and this side is 3 meters, and this is x2. The tangent of 29.6 is equal to opposite over adjacent, that's x2 over 3. So x2 is 3 times tan of 29.6, which is 1.7 meters. So, to find x, I say x is equal to x1 plus x2. That is 0.84 plus 1.7, which is 2.5 or 2.5 meters. Alright, use a matrix method to solve this system of equations. Quite a few of you got this actually, so which I was glad for. You have, I'm going to rewrite these equations. The final answer was x equal 1, y equal 2, and z equal 3. Write this first equation as 1, 2, 0, and 5. This is 1, 3, 0, and 7, 2, 4, 1, and 13. And there are a variety of ways you can do this. Let's see, we could let's replace row 3 with row 3 minus 2 row 1. Alright, so we'll minus 2 times row 1. So that works out where I get 1, 2, 0, 5, 1, 3, 0, 7, and then 2 minus 2 times row 1, that's 2 minus 2 times 1, that's 0, and then 4 minus 2 times 2, that's 4 minus 4, which is 0, and then 1 minus 0 is 1, and then 13 minus 5, minus 2 times 5 is 10. So that gives one of the rows in the proper way. let's substitute row 2 with row 2 minus row 1. And so that gives me 1, 2, 0. Let me write it up here. Gives me 1, 2, 0, 5. 1 minus 1 is 0. 3 minus 2 is 1. 0 minus 0 is 0. And 7 minus 5 is 2. And then we already had 0, 0, 1, 3. And now we just need to get rid of row 1. So we'll substitute row 1 with row 1 minus 2 times row 2. So that's 1 minus 2 times 0, which is 1. 2 minus 2 times 1, which is 0. 0 minus 2 times 0 is 0. 5 minus 2 times 2, which is 5 minus 4, which is 1. And then 0, 1, 0, 2, 0, 0, 1, 3. It was a relatively easy matrix. X equals 1, y equals 2, z equals 3. And I gave you 3 extra credit points for that. I also gave partial credit for this, so if you just got it part right, I gave you 1 or 2 points.